Good afternoon. Today we're looking at packet number 7. It is due on February 13th, next week, Tuesday. Our first page says, the Brookville Badgers are competing in a grueling 12-mile relay race. Coach Thompson met with the 4-member team and gave them the following instructions. Martin will run 1/4 the entire distance. So let's say this is our entire distance. Martin's running 1/4 of it, so I'm going to break it up into fourths. Martin is running 1/4. The next third of the distance, I've got 3 squares left. The next third, Ben is going to run. And Corey will cover half of the remaining distance. And Jason will run the rest of the way. When we make a picture, it really helps us see how much each person is running. So as we're breaking it up, you should be able to see how much, who is going to run that furthest distance. Okay, so you're just going to, but you have to show your work, how you came up with your answer. Our second page. Create a data set with 5 values, 5 numbers that are going to have a mean of 20, a median of 18, and a mode of 15. Remember, mode is the most. Put the book away, please. This is math class. Mode is the most. The median is the number in the middle. So if they tell you what the median has to be, they tell you what the mode has to be. That already gives you some of the numbers in your data set. Then you need to finish up your data set, making sure you have a mean of 20. You add all 5 numbers together, divide by 5, and you will get 20. So you need to figure out where those numbers are going to fall to make sure that your mean is 20, your median is 18, and your mode is 15. Keeping in mind there are only 5 values in this set. You might need to play around a little bit with it. For the 5-card challenge, we need to equal 7. We can use a 7 in our equations, but only once. Okay. So our final equation equals that 7. Try to challenge yourself. See how many 5-card challenges you can actually get using all 5 cards. See how many points you can get. Some of us are really content just saying, oh, I got my 15 points, I'm done. Challenge yourself. See how many points you can get. Addie? Okay. Next page is our pattern page. Complete the entire table. So, how many yellow squares are in our figure 1? How many red? 0. So how many total blocks? 1. Right? Figure 1, there's no red. Let's look at figure 2. How many yellow? How many yellow? Oh, 1. 2. How many red, Jude? So how many total? We'll look at number 3. 1 yellow. How many red?
24.
How many total?
25.
Look at figure 4. How many yellow? How many red?
48.
How many total?
49.
So, is there a column that I can fill in easily right now? James? Really? There's one that's even easier to fill in, James. Lately? The yellow. There's 1 yellow in each one. Right? That's the easiest one to fill in. Now if I look at my total blocks, can I see a pattern? I'm going to give you a clue. Who remembers what my favorite kind of numbers are? Lucas? Not primes. Grace? Perfect squares. Love perfect squares. They come up all the time. If we look at 1, 1 is a perfect square of what? 1 times 1. Look at 9. What is 9 a perfect square of? 3 times 3. 5 times 5.
7.
Oh my, am I just seeing a pattern? Ooh. Look at that pattern there. If I can fill in my total blocks with my pattern, and I know my yellows are all 1, am I going to be able to figure out how many reds there are in each one? I just have to subtract 1 from it, right? Yeah.
I had another pattern I saw, but now I can't see.
My pattern makes sense? Especially when it comes to these logic pattern ones, always look to see if there's perfect squares. All right, next one. Find the area of the figure and the shaded region. So our figure is, I've had a few people ask me about this. The figure is this full rectangle. That is our full figure. When it says area of figure, it is that full rectangle. How do we find the area of a rectangle? Length times width. So what are you multiplying together to get that full area? Then we need to know the area of the shaded region. How do I find that shaded region? That is a goofy shape. I don't know what to multiply together for it. Grace?
Find the area of the circle and the square in it, and then minus it by.
I'm going to find the area of the circle and the area of the square. Those are my 2 white ones that I want to subtract out. And then I'm left with the shaded. How do I find the area of a circle? Pi r squared. How do I find the area of a square? Length times width. So find the area of your 2 white shapes. Subtract it away from your full area, your area of the figure, and you're left with just the shaded region. So you're subtracting out the 2 white shapes, and you're left with your shaded. Let's look at our next page. Surface area of a sphere.
How do we print that, please?
I'm sorry, what?
How do we draw the net?
Yeah, Henry? What am I doing right now? Am I walking you through every page? Do you think I'm going to say, yeah, figure it out on your own, or do you think I'm going to help you out with it? I'm seriously asking, Henry. Do you think I'm going to help you out with that? So do we need to yell out, how do we find that? Or do we just need to practice our spiritual work of mercy of being patient? I think we need to have a little patience. Okay. So the first thing we always have to do when we come to this page is to draw our net. We don't have the net of a sphere on my back cupboard there. It is a goofy shape. Some of us have looked it up already and have a clue as to what a sphere net looks like. I had to look it up because I don't always know how it would lay out flat. So it kind of looks like a beach ball. Kind of got cut up on its seams. And you've got the 2 ends of our beach ball. And then you have our sections. So we've got like 2 circles, and then we have our panels for each section. So you can envision it in your mind that when you wrap it all together, oh, it's going to all fold up, roll up to be that sphere shape. I'm sorry, what? I did 5. Yeah. How did I what? It doesn't look good compared to what it looks like on the internet. It doesn't have to be perfect by any means. Second thing we have to do is find the figure's surface area. So you need to know the formula for the surface area of a sphere. It is 4 times pi times r squared. So 4 pi r squared. That's what we need to do in order to find our surface area. Now our next page is not surface area anymore. The next page, remember, has to do with our volume. So it is not, some of us tried using the same formula. They are two different things. Surface area is around the outside. Volume is how much fits inside of it. So our formula is different. So the formula for a sphere is 4/3 times pi times r cubed. 4/3 times pi times r cubed. So when you're putting it into your calculator, 4/3 is 4 divided by 3 times pi times r cubed.
Oh.
4 divided by 3 times pi times,
It looks like
times 9 cubed. You put the answer right here.
That's kind of a weird number.
Then it says a rubber sphere with a radius of 3 centimeters is put inside that original sphere. What percentage, so your answer needs to be a percentage, of the original sphere's volume remains available? So figure out the volume of the rubber sphere. We know the volume of the original sphere. Subtract it out to see how much is remaining, and then find the percentage. Okay. So you have to find the volume of the small rubber sphere, subtract it from the original sphere, and then you need to find what percentage is remaining. So your answer should be a percent. Let's look at our next page. Fibonacci numbers. I had somebody come up to me and say, Psh, it's Fibonacci numbers. I don't know what that means. I have no idea how to do this page. And I said, well, did you read it? And I said, oh, no. I just saw a new word that I didn't know what it meant. And so I came for help. Always, always, always read the directions first and see if you can figure it out based on the directions. So one of the more famous mathematical sequences is the Fibonacci numbers. A number in the sequence is equal to the sum of the previous two numbers. What does sum mean? What operation, Dominic? Add them. So you have to add the two numbers before, and you get the next number. So we need to fill in the Fibonacci sequence as we're going. So 1 plus 1 gave us 2. 1 plus 2 gives us 3. 2 plus 3 gives us 5. 3 plus 5 is 8. 5 plus 8,
13.
And you're going to continue that on. Matthew, that's not participating in class. That's distracting people and being obnoxious. Let's not do that. Thank you. So continue on. This frequency, the frequency with which these numbers appear in mathematics is astounding. We will explore some of the patterns and applications of Fibonacci sequence in our logic packets. So we're going to see this more, just like we've seen Pascal's stuff in logic. Now we're going to see some repeating, Fibonacci stuff. We're going to be working with his numbers. Next page. Identify the expressions that are equivalent to the given expression. Defend your decision. Now this is important. When you defend your decision, it doesn't just mean that you show me what the answer is. It means you explain it. You're defending it. Words. So on mine, I have words that I wrote out. So you need to see which of each of these expressions equals 1. And you need to say why it equals 1. Okay, so you need to do the math, see what you get for each one of those, and you need to say either yes or no. Yes, it equals 1, or no, it does not. It's not funny. It's just a direction. Dominic shouldn't be turning and looking at Matthew. Dominic should be looking at me. Yes, I realize Matthew is sitting there. Should that be an uproar? No. I'm okay with it. I know where his seat is. Your attention should be up here, Madden. Right? Okay. So, defend it. If you think the answer is 1, why? Kaylin?
When I was reading it, I didn't know 1 was the given expression.
Yes, the given expression is 1. So find which one of the things below equals 1. And either say yes or no, it equals 1. Lauren. It means it's a variable. If you put any number in for n, it could be 2, it could be 10, it could be 1,000. Would it equal 1? Lucas.
Can more than one equal 1?
We're looking at each one individually.
I know.
Yes or no, yes or no, yes or no, yes or no. You figure it out. You have to look at each one. You don't just say, oh, this is the one that equals 1. No, you look at each one individually. Does this equal 1? And our last page is our polyominoes. So see how they fit into our leafy shape there. So that is it for packet number 7. It is due next week, Tuesday. Have a wonderful day.